In this video, we'll take up the homework on sums and differences of functions homework. So for the first question, they give us f and g. They're both linear functions, and they ask us to write an equation for the sum of f and g, and then ask us to evaluate at h of 2, or the sum of the function at 2. Then they ask us to find the difference of f and g, and then also evaluate that function at 2. So not much to say, but just remember for the difference of f and g, make sure to put g in brackets, otherwise you will get the wrong answer. For question 2, they ask us to graph 3 functions on the same set of axes. So they want us to graph x squared, 1 over x, and the sum of f and g. So it's not very pretty. I would recommend you to use a graph paper and do it properly and show yourself the scale, and then check your answer with Desmos or some online graphing software. Anyways, for 3b, they ask us to state the domain and the range. So for the domain, just remember that the domain of the sum or difference of 2 functions can be found by determining the common elements. What are the same parts to the 2 domains? So what do the domain of f and g have in common? And that will be the domain of the sum or the difference. In this case, we're working with the sum of f and g. So I found that by looking at the domain of x squared and 1 over x. So everything is defined for the 2 functions except for x equals 0, because 1 over x is undefined and x equals 0. As for the range, just look at the graph that you created for 2a. For question 2c, they ask us whether the end behavior of the function, the sum, does it behave like f or does it behave like g? If you look at the graph, it clearly behaves like f of x, because it's approaching as the values of x, as the magnitude of x gets very large, the output values approach infinity. And that makes sense that it behaves more like f of x, because g of x is asymptotic, it's approaching 0, so its impact on the output values is minimal. So yeah, it behaves more like f of x. For question 3, we have the cost function, the revenue function, the profit function. Not much to say, it's just like our handout that we did together. And they ask us when did they break even. So let P of n equal 0 when the profit and the when the revenue and the cost are equal to one another. So that's after 30 units sold. And then find the domain for the profit function and for the range for the profit function. So I use the roster notation just to list out the values. You could use set builder notation and say like n is an element of integers from 0 to 200. That's also fine. Okay, and then for 3f, they ask us what would the variable cost be if they want us to have a break-even point at 20 units sold. So I did the math, and then I solved for x to be 75. So that means I need the variable cost to be $175 per unit sold, because this coefficient was found, where was it here? You want 250 and 200 here. You want the difference to be 75. So since you're only allowed to change this coefficient for the variable cost, since the difference between the revenue and the variable cost is 75 instead of 50, then we have to drop this to 175 in order to reach break-even point at 20 units sold instead of 30 units sold. Okay, so very hopefully straightforward homework sheet.